So this is question 11 from 2FA3 Review Part 2, the lab in which you were looking at factors that affect the rates of reactions by using Alka-Seltzer. So question 11 addresses learning targets 2.2.3 and 2.3.3, so a 2.0 and a 3.0. 2.2.3 is make the conclusion, and then 2.3.3 is to justify your conclusion with evidence, scientific knowledge, observations, etc. So in question 11 it says, which reaction conditions, temperature and particle size, resulted in the most frequent collisions? So with this, it's important that you mention both the temperature condition and the particle size condition. So for this conclusion, it should be that hot water and the small particles, so powdered would be our small particle size, resulted in the most frequent collisions. Evidence for this actually comes from our data. So if we look at our data table, we can see that our shortest reaction time happened to be our powdered and our hot water. So we can see 18 seconds. So hot water and our powdered, our small particle size, resulted in the most frequent collisions. And we know this because collisions are what cause chemical reactions to take place. So the faster the reaction, the more collisions must be happening. So we chose hot water and powdered because it had the shortest reaction time, and having the shortest reaction time must have meant that there were the most collisions, because the more collisions you have, the faster the reaction occurs. So question 12 is very similar, except in the opposite direction, because it asked which one would have the least frequent collisions. So the most was the shortest time, so the least would be the longest time. So if we look at our data, the longest time that we got was our whole, meaning our uncrushed piece, and in the cold water. So our conclusion would be cold water and whole Alka-Seltzer, so the large particle size, resulted in the least frequent collisions. And we know this based on our background information. The fewer the collisions, the longer the reaction is going to take place. And this also makes sense with particle size, because if you have a large particle, that means that there is less surface area for reactions to take place. So the trial using the cold water and the whole Alka-Seltzer had the longest reaction time. The whole piece had the largest particle size, giving it the smallest surface area for reaction. This results in fewer collisions. Also, the cold water means that the particles are moving more slowly, resulting in the least number of collisions. So the fewer the collisions, the longer the reaction takes, the longer the reaction time, which is why we chose cold water and whole Alka-Seltzer. We can see the time was 1 minute and 47 seconds. For the last question, it's asking us which particle had the largest surface area, or which type of Alka-Seltzer had the largest surface area for reacting. The whole tablet, the crushed, or the powder. And what this really means is which one had the most particles available for collisions to occur. And so based on our data table, what we're going to look at is we want to look at which trials had the fastest reaction time. And if we look overall, the powdered had the fastest reaction time regardless of the temperature. So our conclusion that we're going to make is that the powdered Alka-Seltzer has the largest surface area for reacting, meaning when we took that same mass of Alka-Seltzer tablet and crushed it up, it provided more places or more opportunities for collisions to occur. The more collisions, the faster the reactions, and we could see that we had the fastest reaction time regardless of temperature for powdered. So our conclusion justification is each of the powdered trials was faster than the crushed or the whole piece trials, regardless of the water temperature. If the reaction happened faster, then there must be more surfaces for collisions to happen. So the greater the surface area, the faster the reaction, And again, if we're looking at our data table, it showed us that for all of our powdered trials, so our powdered trials here, we had the shortest reaction time regardless of the temperature. Okay,